Divide and conquer is an approach for solving larger problems by dividing them into smaller problems, which can be easily solved. We can use this strategy to sort an array. An algorithm we are going to use today is called as merge sort. If you have two sorted arrays, will you be able to combine them while keeping the resulting array sorted? Let's see how we can combine them. Suppose you have two sorted arrays containing a single element. First one is 5 and second one is 3. What will you do? It is trivial. You will compare those two and put the smaller element first. In our case, 3 is smaller, so we put 3 followed by 5. Easy. But what if the sorted array had many elements? You can still use the same logic, but this time compare the elements one by one. Assume that we have two sorted arrays A1 and A2. We look at first element from both arrays. Suppose the element from A1 was smaller, then we add it to our combined array and then we point to the second element in A1. Now we compare the second element of A1 with the first element of A2. We repeat these steps until we have completely iterated over an array. Then we just append the remaining elements to the combined array. And this is how we combine two sorted arrays. But what this has to do with our original problem? Let's frame our problem. We have to sort an array containing n integers in ascending order. Now, can you think of something that can be solved very easily? What if our n is 1? If there is only one element in an array, we can say that array is sorted. Interesting. But what next? From here, we can go on and keep combining the sorted arrays to get our final array sorted. Isn't this amazing? This algorithm is called merge sort because we sort our array by merging two sorted subarrays. Enough there. Let's see how we can code it. Here we have a merge routine function which takes two sorted arrays and merge them in sorted order. In the merge sort function, we are going to use recursion. So we first set our base case that if the length of array is 1, then it is already sorted, we just return it as it is. If that is not the case, then we find the mid of array and call merge sort function recursively on the left part and right part. In each call, we return the merged sorted array. What is the complexity of merge sort? The time complexity is theta n log n. We can get this by solving the recurrence relation as shown. And the space complexity is theta n because we are creating a new array of same size which is sorted. Now let's verify if the code is working by executing it. I am using Python 3 and yes, you can see it sorted our array. If you want the array to be in descending order, you can just change the comparison sign in merge routine. See, it is now in descending order. Easy, right? But can you do it iteratively? Yeah, you know the drill. Go and try implementing it recursively and iteratively in whichever programming language you prefer. Let me know in comments were you able to do it or not. We will meet again in next video. Till then, stay tuned for it and keep coding.